The authority responsible for determining the classification of an industrial hazardous classified location is typically the local authority having jurisdiction, often referred to as the AHJ. These AHJ are the governing bodies that enforce safety regulations and building codes. They play a crucial role in ensuring that industrial facilities meet the necessary safety standards to prevent explosions and fires in areas where flammable or combustible materials are present. The AHJ responsibilities extend to various aspects of hazardous location classification, including reviewing facility plans, conducting site inspections, and issuing permits. Firstly, municipal building inspectors might act as the AHJ. These inspectors are responsible for enforcing local building codes and ordinances, which often include regulations related to hazardous locations. They review building plans to ensure that electrical systems and other equipment comply with the applicable codes and standards. Secondly, state or federal safety agencies may serve as the AHJ. These agencies are responsible for enforcing safety regulations at the state or federal level. They conduct inspections of industrial facilities to ensure compliance with safety standards and investigate accidents and incidents. Thirdly, fire marshals can be the AHJ. Fire marshals are responsible for enforcing fire codes and regulations. They conduct inspections of industrial facilities to identify fire hazards and ensure the fire protection systems are properly installed and maintained. Fourthly, insurance companies sometimes act as the AHJ. Insurance companies have a vested interest in preventing accidents and incidents that could result in financial losses. They may conduct their own inspections of industrial facilities and require compliance with specific safety standards as a condition of insurance coverage. The AHA uses established codes and standards such as the National Electrical Code, often abbreviated as NEC, and Occupational Safety and Health Administration, known as OSHA, regulations to assess the risks and hazards in a location and determine the appropriate classification. The National Electrical Code, or NEC, is a widely adopted code that provides detailed requirements for electrical installations in hazardous locations. It classifies hazardous locations based on the type of flammable or combustible material present, the likelihood of its presence, and the potential for ignition. OSHA also has regulations that address hazardous locations. These regulations require employers to protect employees from the hazards of flammable and combustible materials. The AHA uses these codes and standards to determine the appropriate classification for a hazardous location. This classification is based on several factors, including the type of hazardous material present, the quantity of the material, the ventilation in the area, and the presence of ignition sources. Once the AHA has determined a classification of a hazardous location, they will specify the requirements for electrical equipment and wiring in that location. These requirements are designed to prevent explosions and fires. For example, in a Class 1, Division 1 location, which is an area where flammable gases or vapors are present under normal operating conditions, all electrical equipment must be explosion-proof. Explosion-proof equipment is designed to contain an internal explosion without igniting the surrounding atmosphere. In a Class 1, Division 2 location, which is an area where flammable gases or vapors are present only under abnormal conditions, electrical equipment must be either explosion-proof or intrinsically safe. Intrinsically safe equipment is designed to not release enough energy to ignite a flammable atmosphere. The AHA also specifies requirements for wiring in hazardous locations. Wiring must be installed in a way that prevents the ignition of flammable materials. For example, wiring must be run in conduit or cable with a gas-tight seal. The AHA plays a vital role in ensuring the safety of industrial facilities by determining the classification of hazardous locations and enforcing the applicable codes and standards. The process of classifying a hazardous location involves several steps. Firstly, identifying the hazardous materials present is crucial. This involves determining the types of flammable gases, vapors, liquids, or combustible dust that may be present in the area. Information on these materials can be found in safety data sheets, often abbreviated as SDS, and other sources. Secondly, assessing the properties of the hazardous materials is necessary. This includes determining their flash points, ignition temperatures, explosive limits, and other relevant properties. This information is also typically found in SDS. Thirdly, determining the likelihood of a flammable atmosphere being present is key. This involves assessing the frequency and duration of releases of flammable materials. Factors to consider include the design of the equipment, the operating procedures, and the maintenance practices. Fourthly, evaluating the potential for ignition is important. This involves identifying potential ignition sources such as electrical equipment, open flames, and hot surfaces. The AHA then uses this information to classify the hazardous location according to the NEC or other applicable standards. The NEC classifies hazardous locations into 3 classes, 2 divisions, and several groups. The classes are Class 1, Class 2, and Class 3. Class 1 locations are those where flammable gases or vapors are present or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Class 2 locations are those where combustible dust is present. Class 3 locations are those where ignitable fibers or flyings are present but not likely to be in suspension in the air in quantities sufficient to produce ignitable mixtures. Each class is further divided into 2 divisions. Division 1 locations are those where the hazardous material is present under normal operating conditions. Division 2 locations are those where the hazardous material is present only under abnormal conditions, such as a spill or leak. The NEC also groups hazardous materials based on their ignition characteristics. These groups are Group A, Group B, Group C, Group D, Group E, Group F, and Group G. Group A includes acetylene. Group B includes hydrogen. Group C includes ethyl ether. Group D includes gasoline. Group E includes metal dusts such as aluminum and magnesium. Group F includes carbonaceous dusts such as coal and coke dust. Group G includes grain dust such as wheat and corn dust. Once the AHJ has classified the hazardous location, they will specify the requirements for electrical equipment and wiring in that location. These requirements are designed to prevent explosions and fires. Electrical equipment in hazardous locations must be approved for use in the specific class, division, and group of the location. Approved equipment is designed to prevent the ignition of flammable materials. There are several different types of approved equipment. Explosion-proof equipment is designed to contain an internal explosion without igniting the surrounding atmosphere. Intrinsically safe equipment is designed to not release enough energy to ignite a flammable atmosphere. Non-incentive equipment is designed to not produce sparks or hot surfaces that could ignite a flammable atmosphere. Dust ignition-proof equipment is designed to prevent the ingress of dust that could ignite. Wiring in hazardous locations must also be installed in a way that prevents the ignition of flammable materials. Wiring must be run in conduit or cable with a gas-tight seal. The conduit or cable must be approved for use in the specific class, division, and group of the location. The AHJ may also require other safety measures, such as ventilation, fire suppression systems, and employee training. Ventilation can help to prevent the accumulation of flammable materials in the air. Fire suppression systems can help to extinguish fires quickly. Employee training can help employees to understand the hazards of flammable materials and how to work safely in hazardous locations. It is important to note that the AHA is the final authority on the classification of hazardous locations. If there is any disagreement about the classification of a location, the AHA decision is binding. Understanding the role of the AHA and the process of classifying hazardous locations is essential for ensuring the safety of industrial facilities. By following the applicable codes and standards, and by working closely with the AHA, it is possible to prevent explosions and fires in hazardous locations. The specific requirements for electrical equipment and wiring in hazardous locations are outlined in the NEC. Some of the key articles in the NEC that address hazardous locations include Article 500, which covers general requirements for hazardous locations. Article 501 covers Class 1 locations. Article 502 covers Class 2 locations. Article 503 covers Class 3 locations. Article 504 covers intrinsically safe systems. Article 505 covers some classified locations. Article 506 covers dust ignition-proof enclosures. These articles provide detailed guidance on the selection, installation, and maintenance of electrical equipment and wiring in hazardous locations. In addition to the NEC, other standards and guidelines may also be applicable to hazardous locations. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, referred to as IEE, the International Society of Automation, known as ISA, and the American Petroleum Institute, labeled API. These standards provide additional information on specific aspects of hazardous location safety, such as grounding, bonding, and surge protection. The AHA may also have their own local requirements that must be followed. It is important to consult with the AHA to determine the specific requirements for a given hazardous location. Proper hazardous location classification and the implementation of appropriate safety measures are crucial for protecting people and property from the hazards of flammable and combustible materials. By understanding the role of the AHA, the applicable codes and standards, and the specific requirements for electrical equipment and wiring, it is possible to create a safe working environment in industrial facilities. The classification process also involves understanding the concept of temperature codes or T-codes. T-codes indicate the maximum surface temperature that electrical equipment can reach under normal operating conditions. This is important because if the surface temperature of the equipment exceeds the ignition temperature of the surrounding flammable material, it can cause an explosion or fire. The NEC requires that electrical equipment in hazardous locations be marked with a T-code that is appropriate for the specific hazardous material present. For example, if the hazardous material is gasoline, which has an ignition temperature of 495 degrees Fahrenheit, the electrical equipment must be marked with a T-code that indicates a maximum surface temperature of less than 495 degrees Fahrenheit. The T-codes are typically expressed as a T followed by a number, such as tone T2, T3, T4, T5, and 6. The lower the number, the lower the maximum surface temperature. For example, a tone code indicates a maximum surface temperature of 842 degrees Fahrenheit, while a 6 code indicates a maximum surface temperature of 185 degrees Fahrenheit. The AHA will consider the T-codes of electrical equipment when determining the appropriate classification for a hazardous location. They will ensure that the equipment is marked with a T-code that is appropriate for the specific hazardous material present and that the equipment is installed in a way that prevents it from exceeding its maximum surface temperature. Another important aspect of hazardous location classification is the concept of intrinsically safe circuits. Intrinsically safe circuits are designed to not release enough energy to ignite a flammable atmosphere, even under fault conditions. This is achieved by limiting the voltage and current in the circuit to levels that are below the minimum ignition energy of the flammable material. Intrinsically safe circuits are often used in hazardous locations where it is not possible or practical to use explosion-proof equipment. For example, intrinsically safe circuits are commonly used for instrumentation and control systems. The NEC provides detailed requirements for the design and installation of intrinsically safe circuits. These requirements are intended to ensure that the circuits are safe to use in hazardous locations. The AHA will review the design of intrinsically safe circuits to ensure that they comply with the NEC requirements. They will also inspect the installation of the circuits to ensure that they are properly installed and maintained. In addition to the technical aspects of hazardous location classification, it is also important to consider the human factors. Human error is a common cause of accidents in hazardous locations. It is therefore important to train employees on the hazards of flammable materials and how to work safely in hazardous locations. Training should cover topics such as the proper use of electrical equipment, the importance of following safety procedures, and the steps to take in the event of an emergency. The AHA may require employers to provide training to employees who work in hazardous locations. They may also conduct inspections to ensure that employees are properly trained and that they are following safety procedures. Hazardous location classification is a complex and multifaceted process. It requires a thorough understanding of the applicable codes and standards, the properties of flammable materials, and the potential ignition sources. By working closely with the AHJ and by following the applicable safety procedures, it is possible to create a safe working environment in industrial facilities.